right, thank you everybody, and we may.
Okay, finally. Sorry, a little late on that one, but we're here, and we're here for our last session of the event, but definitely a good anchor session. So this one is called From Chaos Order, Autonomy and Traffic Management. We're talking about, the growth in air vehicles and the small UAV class, increases in the launch of multiple mega satellite constellations. Traffic management is in both air and space is affecting a lot of our constituent communities. So in this discussion, our panel will examine the regulatory, technical, and practical aspects of traffic management, both down here and up there. So our moderator for this panel is Kevin O'Connell, founder and CEO of Space Economy Rising. Kevin, I turn it over to you. Take it away.
Jim, thanks very much for the introduction. Good afternoon, everyone. And I'm delighted to be here for this final panel on autonomy and traffic management. For the next hour, we'll talk about that. And as Jim said, with the growth in UAS activity, as well as the increased launch cadence of satellites and other space objects, we really have to think hard about how to bring new tools to the traffic management functions. I'm delighted today to be joined by an exceptional panel, and I'm going to use the order that we had in the published document. Colonel Nathan Diller, Director of AFworks, Dr. Marie Bajah of the University of Texas at Austin, Fred Judson from the Ohio UAS Center, and Patrick Besha, a Senior Policy Advisor at NASA. Over the past few days, participants in this workshop have interacted about exciting new enablers for and innovations in space. For the spacefarers out there, we have talked about developments that will enable space exploration and space commerce. From my perspective, we're quickly moving from a period of a very limited understanding of the value of space to one where space is increasingly recognized as a key enabler, if not the key platform and the backbone of the 21st century information economy. Aside from the tremendous innovations that we're seeing within the space community, fueled by government activities, industry activities, finance, and others, we're also seeing companies from other sectors increasingly begin to experiment with space capabilities, given the increased availability of access to space. We're seeing this starting with the trio of remote sensing, IoT, and high-speed communications, but it's going to extend well beyond that. Think about it as a development not unlike the advent of desktop computing in the 1960s and 1970s. To say it another way, space is the platform that will fuel ag tech, clean tech, ed tech, and many, many other innovations, while deepening our understanding of developments on this planet and enabling exploration and habitation of space. The challenge in space, to the point of this panel, and arguably the most important, is space debris and congestion. Space debris threatens the astronauts aboard the International Space Station, the billions of dollars of investment in space that is already there, and the growth of space commerce. It's a problem that is urgent and continues to grow, and solutions have to be developed that keep up at speed with the problem as the space environment grows more complex. By some estimates, as many as 100,000 satellites will be launched by the end of this decade. In addition to larger numbers, however, we're also going to see new missions like space ferries and rendezvous proximity operations that will add to the complexity that I'm talking about. This places a real premium on autonomous maneuver capabilities and more accurate and timely warnings to space operators. There are at least 4 tools in our toolkit for mitigating the space debris problem, namely not creating new space debris, improving our awareness of the space environment, improving communications and warnings between governments and space operators, and active debris removal. While government investments in these areas vary greatly, there's a growing recognition of the roles that academia and the private sector can play in providing solutions. Commercial technologies for data management, analytics, and visualization that often apply in other disciplines need to be applied here quickly, and commercial companies are developing new sensors and other unique tools to address this problem. While some of us will focus on space on this panel, we also need to think about the changing world of aviation and UAS, where both government and private sector activities are growing. There'll be important lessons to learn cross-domain, whether historical or operational or even other. We do need to be careful not to oversimplify, however. Sometimes a temptation, for example, to think that air traffic control and space traffic management are the same thing, separated by distance. They're both about safety, but they're very different in technical terms, legal terms, jurisdictional terms, and others. Space has many, many more non-cooperative bodies, by some counts over 34,000 objects larger than 10 centimeters and 130 million between 1 millimeter and 10 centimeters, including many of what are called lethal non-trackable objects. And obviously that's a problem. These will have to be dealt with. Autonomy and other advanced technologies will play key roles in addressing this and keeping space safe and sustainable. With that, let me turn it over to the other panelists for roughly 5 to 7 minutes per person, and then we'll dive into the discussion. And we'll certainly want to leave time at the end for audience questions. And so thank you. Let me turn first to Colonel Diller.
So this was not necessarily staged. Tell me how you hear.
Good.
Great. So my apologies, but maybe this incident plays directly into the conversation today. While I am connected, wired, and Wi-Fi, I'm actually had to bounce over to my LTE phone right now, and I wish that there was some space-based LEO internet. For whatever reason, I dropped off right after you said we're talking about some of the ag uses of this, which is, I think it starts to get into why we at AFworks, so I'm the director of AFworks, this is the Air Force's innovation organization, why we are kind of taking the approach that we are in capability development in the Air Force and starting to look at what we see as a commercial sector of dual use technologies where approximately 80% of all research and development is happening. If we are going to be competitive in this world, the Department of Defense has really established in the National Defense Strategy the requirement that we start to look at this dual use market. We start to look at other parts, the commercial sector, where we're able to begin absorbing more effectively the technologies that are available. And so that's precisely the purpose of AFworks, is to take our airmen and our guardians. So we are the Department of the Air Force, AFworks, both for the Space Force and the Air Force, taking those great ideas from our airmen and from our guardians and pairing those with the technologies that we're finding in the emerging markets, in many of these markets. And when we look across just over the last couple of years since we've established this model, we have this AFventures group under AFworks. We have made contracts with over 1,800 small businesses since the establishment of this. So over 3,100 contracts out there. Of those, 70% of them are new to working with the Department of the Air Force. And so we see partnership as absolutely essential if we're going to be competitive moving forward in this new environment. And that partnership goes not only to industry, we also spend a lot of time with the investment community. We look to the investment community in many cases to help us do some of the tech scouting, help us understand what those trends are and how we might be able to unlock the potential of some of these commercial markets through engagement with the Department of the Air Force. Besides the investors, we also engage closely with the interagency, obviously with NASA and the FAA, but going beyond that with the Department of Energy, Department of Homeland Security, Department of Health and Human Services, State Commerce, because when we look at these new markets, in many cases there are regulatory restrictions that might have to be overcome as we think about acclimation to the new technologies. And so as we've done that, one of the programs that we've launched in a path to take the great technologies that are out there in the American innovation ecosystem, paired with the great ideas of our airmen and guardians, and together then take them across what we call the Valley of Death, this challenging path of taking those ideas and those technologies and turning them into a new capability. So we've established also AFworks Prime. Our first Prime program is Agility Prime. And Agility Prime is the Air Force's flying car program. We've established that program really for three reasons. One, because we believe that we have to, as a nation, ensure that we don't get behind in the emerging advanced air mobility, urban air mobility, maybe you think rural air mobility, but making sure that this coalescence of electric technologies with the large electric propulsion systems, with autonomy, potentially AI, simplified vehicle operations, and with materials manufacturing, 3D printing, advanced composites, those three coming together, potentially creating an entirely new market under advanced air mobility, and a market that we are looking to, one, participate in. And so we've taken new processes for engaging with industry. And some of those new processes talk specifically to how do we apply autonomy? How do we manage congested airspace when we start to move potentially from large, exquisite systems and fewer of those large systems to many systems working collaboratively together. And so when we look across the commercial ecosystem, we see from an energy perspective, from an autonomy perspective, from sensors, from communication, a wealth of commercial technologies that could have very interesting uses as we think about things like logistics or disaster response, where we would have a resiliency potentially both on the ground with a program like Agility Prime, as we start to think about different approaches to resiliency by using space as well, from a sensor perspective, from looking at multiple spacecraft working collaboratively together. How do we leverage those commercial technologies in an effective way? And so that's where AFworks is looking to engage with that broad partnership in these exciting new technologies, and that partnership really across industry, across the interagency, with investors. And in particular, we've just recently established our international division internal to AFworks, looking to see where there's partnership with nations in ways of taking these technologies and developing for the safety, security, and prosperity of our country. So thanks for the opportunity. Looking forward to the conversation, and I'll try to get a little bit better camera here for you in just a moment. Back over to you.
Thanks very much. Let's turn it over to Mariba.
Hello, everybody, and welcome from any corner of Earth that you may be coming from to today. I lead a transdisciplinary research program at the University of Texas at Austin focused on what I called Space S-cubed, space safety, security, and sustainability. Regarding some safety issues, clearly we've heard about the orbital debris problem, and that is growing. We aren't able to flatten the curve on the proliferation of debris. Mostly, part of the reason we can't flatten the curve on the growth of debris is really because of a lack of compliance with the science. Experts around the globe have come up with some guidelines for debris mitigation. Some of those adopted by the IADC, others by our very own United Nations Committee on Peaceful Uses of Outer Space. And because there's a large lack of compliance with these guidelines, we aren't able to flatten the curve, as they say, on these things. Now, from a space sustainability perspective, some of the issues that we have, and I think that these are extremely critical, is recognizing near-Earth space as a finite resource. We only have so much orbital space, actually, literally and figuratively, to put satellites to perform specific missions. And once those orbital highways become saturated in their carrying capacity, we're gonna have to try to find alternative methods to achieve the same thing. And fighting Mother Nature to do that is a losing proposition. We won't be able to do that. And so we have to take care of the orbital highways that we have and try to find ways to holistically manage and coordinate that carrying capacity. From a space security perspective, we've already heard this notion of dual use technology. Look, I started my career as a cop in the Air Force. I used to guard nuclear missiles at Malmstrom Air Force Base in Montana. And I was taught that a threat required the coexistence of three ingredients: opportunity, capability, and intent to cause harm. Now, with dual use technology, opportunity and capability happen all the time. The question is, how do you infer intent? And unfortunately, what many people do is, because that is very ambiguous, we tend to apply our own prejudice to try to get rid of that uncertainty and just assume that anything that we don't understand is intentionally trying to harm us. That's not to say that real threats aren't out there. Of course they are, and not just geopolitically, but even, one company, Acme Incorporated against, I don't know, Das Vidania LLC. At some point there's going to be a dispute because there's money to be made or lost. And every domain of human existence has seen that. To think that space is different is naive. So the thing is, threats are real. Okay. So given those three S's, how do we manage to coordinate through all that? How do we make heads or tails of who's doing what to whom when? How do we make space more transparent? So what is it? Who does it belong to? What can it do? How can we make space more predictable? Given any situation, what will any two space actors do? I can tell you right now, people don't have the same risk posture in space. Somebody might say, 1e to the -3 collision probability. Let me just yawn for a little bit. I'm not going to do anything. Somebody else might do something, but that's not standardized. Our knowledge about stuff in space is uneven, which means that the practice of space operations is also uneven. And when it's uneven and unpredictable, guess what? That leads to textbook definition of wicked problems. And so we need to have a way to address this. Machines will have to help. There's no way that this scales so that humans can just be the people analyzing stuff. Humans are great at providing context to information, and I'd say much better than machines are. But machines can evaluate hyperdimensional data cubes of heterogeneous data in ways that humans cannot. So we need automation, but it needs to be smart automation. It needs to be collaborative automation. And we're really facing a complex system in that there are causal relationships in this domain that we don't know. They're hidden. It's very nonlinear, meaning a small cause can have a huge consequence, butterfly effect kind of thing. And the emergent behavior that we see in the domain is not explained through superposition. That means just by observing individual behaviors and adding those up does not explain the actual observed behavior of the domain. So all of these are things that we need to dive more deeply into. And in the interest of time, I'm just going to leave it there.
Thank you. Let's go to Fred.
Thank you, Kevin. Fred Jetson, Director of the Howe UES Center, part of Drive Ohio. So so it's weird having an air component in something that's called Drive. But I think, so we at the Department of Transportation look at autonomy, both air and ground. I think I got the better side and I've got the air side. But then I'm a little envious at my space colleagues on this panel. So, so getting into the Ohio UAS Center, we're the lead for Ohio's Fly Ohio efforts, and we're talking the positioning Ohio in the advanced air mobility realm. And I want to just spend just a second on defining what we see as advanced air mobility, and that is the integration of aircraft of all sizes and all levels of autonomy into the national airspace system, and making sure that Ohio is prepared for that. Just to give a little bit of background, we commissioned an economic impact study of advanced air mobility technologies for Ohio that's out, that you guys can probably pull up from a Google search or email me after. Some of the statistics that we are able to pull out is advanced air mobility over the next 25 years, meaning $13 billion of economic activity, 16,000 new jobs created for just in advanced air mobility, movement of 8 million additional people across the state per year, which is if you think of a helipad handling quite a few number of people, is a lot of demand on what is now called a vertiport. But getting into vertiports, we're projecting over 81 new vertiports for the state of Ohio over the next 25 years, just dedicated to advanced air mobility. So the Department of Transportation in Ohio realizes that there's a lot of new investments and activities that need to take place to make sure the state is prepared for this new or enhanced mode of transportation. Some of that infrastructure that we operate, and I'm going to give a few examples. We have our unmanned aircraft traffic management project that is a detect and avoidance service that looks at the altitudes of 0 to 2,000 feet to ensure that we're able to operate safely and not collide with any other aircraft that's out there. We have our Sky Vision asset that's located at our Springfield Beckley Airport that is also a detect and avoidance system operating in the altitudes of 1,000-foot AGL to 10,000 feet MSL. That is in partnership with Air Force Research Labs and is a beyond line, where Air Force Research Labs has a beyond line of sight certificate of authorization without the need for observers. We perform detect and avoidance services that enables a 200 square mile area for the testing and research of these new aircraft technologies. Just a few weeks ago, we were announced as under the NASA ACO3 for community outreach for advanced air mobility, and that's in support of the NASA national campaign. So we are aligning all of our Ohio stakeholders, both local, regional, and state government entities in educating them in outreach on what the new aviation technologies that are coming online will mean for their communities and how we'll actually integrate them into Ohio. And lastly, I'm going to mention our vertiport planning that we are also working with NASA on, analyzing our different urbanized areas and giving our local representatives a good idea where some of these new advanced aircraft technologies will be operating in and out of. So with that, I'll go ahead and pass it to the next panelist.
Thanks, Fred. Why don't we turn it over to Patrick?
Hi, I appreciate the opportunity to join today's panel. So I'd like to talk about space debris and space traffic management. But first, I note that today's title of today's panel is Convergence, Deep Space, Near Space, and Aeronautics coming together. So while comparisons of air traffic management and space traffic management are imprecise and somewhat of a conceptual mismatch, I think at a very high level, comparing the two can provide a little bit of food for thought. Now, consider that the safety of global air travel has improved by orders of magnitude since the 1960s. Part of this was technology, of course, but an important part was also the FAA setting safety standards for US carriers and US airports, and for international carriers that wanted to fly into the US. The FAA also worked with local civil aviation authorities worldwide to set standards. Now, these were not just idle suggestions. These were regulations that were backed by the threat that US airports could bar national airlines and US carriers wouldn't fly into foreign airports. So these potentially could cost millions of dollars a year. So what's the takeaway? Well, while in space, we have nowhere near the leverage available to the FAA that the FAA had. And indeed, the models are different. But it does illustrate how economic incentives are one of the most basic but most effective tools for establishing global standards and norms. Now, we've developed a lot of the standards for space debris and some of them for space traffic, but compliance is currently really low. So the critical question is really, in the absence of any leverage comparable to what exists for air travel, how do we incentivize spacefaring nations and satellite operators to develop rules of the road, right-of-way provisions, and generally agree on principles of responsible behavior in space? How do we incentivize post-mission spacecraft passivation and disposal? So space debris is recognized as a classic tragedy of the commons. I think we're all familiar with this argument. Governments and businesses have very little incentive to bear the costs associated with removing orbital debris. However, debris left in orbit imposes costs on everybody else, all other spacefaring nations and firms. This is a well-known problem in environmental economics, that which nobody owns, nobody cares for. So the standard solution is property rights. However, that's infeasible in this case because while spacecraft may lay claim to some orbital slots in GEO, for example, they cannot claim entire orbits. So for this reason, strong government intervention is sometimes considered the only solution. But, you know, as the Nobel Prize winner Eleanor Ostrom has noted, in actual practice, when users of a common pool resource need a solution, they've tended to develop effective governance mechanisms that combine the bottom-up kind of local initiatives with the top-down and the overarching governance framework. So it's not always the top-down governance solution. So a joint approach may be the way forward. You know, as Kevin mentioned in his introduction, there are four approaches to reducing space debris. You can reduce debris by design, you can characterize the space environment, you can remove or repurpose that debris, and you can do some coordination and data sharing. And NASA is involved in all four of these activities, from characterizing orbital debris, evaluating conjunction assessment risks, developing early stage removal technology, and generally serving as a leader in the US government and the IEDC to push for improvements. I recommend take a look. We recently published a NASA spacecraft conjunction assessment and collision avoidance best practices handbook. Recommend taking a look at that. It's on our website. And still, there exist a number of technical challenges, from inadequate capabilities to monitoring the overall space environment. We have some challenges detecting and monitoring millimeter-sized debris in LEO. We have kind of a lack of understanding about some of the causes of on-orbit explosions. And there also exists some policy, economic, and coordination challenges. As I mentioned, we need to incentivize post-mission disposal, spacecraft disposal and passivation. We need to, one solution could be a disposal bond requirement. That might create an incentive for firms to design and build robust satellites and properly dispose of them. Another idea might be incorporating some of our existing spacecraft disposal guidelines into our procurement and partnership agreements. That could strengthen compliance. Ultimately, coordinating on an international scale will be critical because we don't unilaterally impact the competitiveness of US owners and operators. So that'd be key. You know, socioeconomic analysis of the risk and benefit of space debris and space sustainability could be improved. We realize space is a common pool resource. That is, you know, one actor's use of the resource subtracts from what's available to others. So what are the risks and benefits of large constellations? What are the risks of congested orbits and potential Kessler effects? As Morba explained just a few minutes ago, the complexity of the domain results in emergent behavior that can't really be predicted easily. But, you know, that's fascinating, the phenomenon that's occurring. And ultimately, this is a global issue. We're not the only ones looking at it. ESA has announced, European Space Agency has announced plans for a space debris removal mission in 2025. JAXA, Japanese Space Agency, has their own mission as well, the commercial removal debris demonstration mission, working with Astroscale, you know, a pioneer in this field. So ultimately, given the risks of orbital debris, what should the US do to encourage an effective and robust space traffic management system? Well, some of this was laid out in SPD3, where, you know, which sought to establish organizational authorities and some of the resources necessary to implement a national approach to space safety, stability, and sustainability. The Commerce Department was tasked with creating the open architecture data repository. And, you know, the news just last month at ComStack, Office of Space Commerce announced the development of a demonstration or a prototype OADR system, featuring data from satellite owners and operators, the DoD public catalog, telemetry and tracking data from DoD and commercial sources. So this is a really exciting effort. I'm looking forward to see how it shapes up. Ultimately, these are really global challenges. In my opinion, the US really needs to be a leader by modeling some of the principles of responsible behavior in space, improving public access to space situational awareness data, improving spacecraft design and disposal measures. So ultimately, the common pool resource of space need not be a tragedy, suffer a tragic ending, and that's why a dramatic intervention may be necessary. Back to you, Kevin.
Patrick, thanks a lot. And thanks to everybody for getting us started. I have a few questions to kick us off. I guess the first question would be, where do we think we are on autonomy right now? Are we at the very early stages? And maybe Colonel Diller and even Mariba can talk about what they're seeing in terms of the science or the commercial opportunities to take this on. Throw it up to the whole group, but where are we exactly? We're still in the early days, or we have a long way to go, and things like that.
So just briefly, I think part of the reason that we're encouraged and the reason we've been looking at some of the space logistics and in particular orbital debris is that we're finding in many cases the technology really is a bit ahead of where we might be from a policy perspective, where we might be from creating, right, to some degree creating the market, as was noted, the fact that there is clearly limited space there, that this potentially is a broader responsibility than you might get just out of commercial interest. But at the same time, I think the other thing that is compelling is the fact that the associated technologies really could unlock a lot of other commercial capabilities. And so from that perspective, we see opportunity for collaboration.
Excellent.
Yeah.
Go ahead.
I guess from my perspective, look, at least with like the Starlinks and stuff, you can show that you can automate maneuvers based on some information piped up to these satellites. So, I mean, that's definitely not a big hooray for autonomy in my opinion. NASA has shown, especially when it comes to, guidance, navigation, and control, really great autonomy. So I think that's solid. Autonomous guidance, navigation, and control, NASA has that kind of down cold, and we're going to need that technology to be spun off, commercially and that sort of stuff for sure. I think the place where autonomy is really lacking is that we don't have intelligent space systems. We don't have space systems that can have enough compute power on board or on orbit to avail themselves of, and where the satellites themselves with edge computing can react to an evolving environment. We don't have that. And the thing is, we need to get to that place, right? But this is where I become a little bit afraid because, people, for whatever reason, tend to think that AI and ML is the answer to everything. And, and physics needs to be part of this, needs to be informing the AI and ML. And what I tell people is that AI ML says that tomorrow looks like today. And so if you feed it a very constrained version of today, you're not going to get a good prediction of tomorrow. You need to feed it lots of todays with a lot of variance of todays. And the more rigorous and comprehensive you can do in feeding it todays, in that measure, you have at least a hope of getting something reasonable for tomorrow. But ML is as dumb as an earthworm. You know what I'm saying? It's not smarts. Humans are the ones that are coding this stuff. So there you go. That's the limitation.
No. Anyone else on this, by the way? Mariba, as I think we chatted briefly before the session began, it's not just autonomy for autonomy's sake. It's autonomy in the interest of collaborating with others in the space case, in the interest of space safety and sustainability, and all those other things that we've talked about so far. Where's the human in all this, by the way? Is the human out? Is the human done in this? The human has to set thresholds up front. Are they the final decider? Maybe I'll ask Fred to comment on this as well in the airspace. Go ahead.
Yeah, I think it would be it would be interesting, because we're looking at the advent of real personal air travel, right? For the airspace. But to add another variable to all the machine learning that needs to go on, what happens when we added personal space vehicles to traffic control problems? But it is trying to predict variables and trying to maintain a level of safety that you're not going to hit space debris or another aircraft in the airspace. It really you know, there's some parallels there, even though there's a lot of differences between the air and space side.
I think the human has to stay in the loop for many of the key decisions that go on here. The question is, how do we decide which ones stay in the hands of the human or that stay in the hands of the machine? And I think there's a lot of good people working on those questions.
Yeah. I mean, look, so I really like augmented intelligence versus artificial intelligence. I like when machines augment human capabilities. Humans are great at, again, context for information. Humans can do that a lot better than machines can. So somehow there needs to be an engagement and interaction between human and machine. So humans have to be part of this. In terms of the decisions, one of the interesting things, I got a comment, and I'm not going to say from whom, but I got a comment recently saying, we're not going to fund any sort of AI ML where the answer that the machine gives is unknown how the machine arrived at that answer. Like if that's not known with exactness, we're not going to fund that. And then I turned around to this person. I said, look, we need to be cautious for sure, because you don't want to just blind algorithm it, right? But at the same time, when you have people on your team, humans that do really awesome work, right? I've had them. I've had people on my team that it's like, wow, I give them a problem and they solve this stuff and they're consistent in their awesomeness. I don't say, you know what? I'm going to fire you unless you can tell me exactly how you came up with the right answer. We don't do that to people. Why should we expect that we could do that with machines? So at some point, if the machines, and this gets to the decision making, if the machines are making what we believe are good decisions in a consistent way, even if we don't know exactly every single detail of how it arrived there, maybe we need to, give a little latitude to that sort of thing.
We deal with the same topics. I'm going to use that analogy, by the way, when I talk to others now. That was amazing. But not only in, we have that problem. Not only if we look at unmanned aircraft for data collection purposes, how it arrives to a decision, we have the same question. It goes into a black box, and then what happens to it? They want to know the specific algorithms that they've used to come to a decision. And you're right. So I'm definitely going to use your analogy in the other arguments. Or how does an aircraft make a decision on its own to move out of the way of another aircraft? Exactly. So as long as that level of assurance and safety is maintained, that's really what the end result should be.
Patrick, for you, less of a question than kind of a foot stomp on something you hit on. We could talk about property rights, but I suspect the audience here might not be as interested in that as others would be. So we'll take that offline. But the extent to which you're talking about understanding the economic incentives that underpin safety and sustainability. In my own experience at Commerce and elsewhere, the technical analysis is still lean enough, but the economic analysis is woefully missing. And we found very, very few people focused on that. Love to encourage the academic community, other professionals to spend more time on thinking about the economics of how we encourage people to actually pay more attention to this. It's not that folks don't pay attention to it, we just need more attention to it.
Yeah, absolutely. And Kevin, I have a couple of great points I want to mention on that. But just to quickly, little addendum to the last discussion, if I could play devil's advocate a little bit on the autonomy discussion, what we really are looking for are right-of-way principles and rules of the road, which are fairly well understood and are fairly ingrained. Maybe autonomy might benefit. We might benefit from an autonomous system where the rules are very well laid out and the systems operate the way they're supposed to be. And there's no intervention by people with political aims or whatever it may be that they don't want to move their spacecraft, whatever it is. So it's just to play devil's advocate on that. But the economic incentives piece. I absolutely agree. There's some interesting work being done by the OECD right now, the Organization for Economic and Cooperative Development. They did a report looking at economic and policy incentives and policies, initiatives around space debris. Were published about 2 years ago. Working on a study now with a number of universities looking at some of the risk-benefit analysis around orbital debris. I think there's a lot that we could be studying here. What is that risk benefit? How expensive are ADR missions compared to what the benefit might be? How expensive are some design changes? Deorbit devices, things like that are relatively inexpensive. Spacecraft that can be docked with, should we start designing all spacecraft like that? There's a rich body of work to be done here.
Exactly.
Yeah.
Glad to hear that more of it's being done, obviously, and that's a good news story. The other point I'd make from your commentary was, you referred back to the aviation safety history, and I think there are some important lessons to learn there. And not least of which, though, is that the governance here may be out of sync with the speed of the technology. I often talk about the rules of the road, which is naturally done by diplomatic community internationally, et cetera. And that's just by necessity going to take time. And I suspect that industry will come up with standards, practical standards, a lot faster that we need to pay careful attention to. In the United States, we have to pay attention to it by law, but I think we'll have to pay attention to that dynamic. Both are important, but they're moving at different speeds right now, and probably a greater differential between them than there were in the aviation industry.
Yeah, absolutely agree. I think part of it is some of the motivations, some of the impetus behind it. In aviation industry had, like I talked a little bit about, they had these drivers. You had to comply. There were standards, and you either complied or you missed out on economic opportunities. Whereas that doesn't really exist right now, and so the governance is taking a long time to get up to speed and to match the technology.
Excellent.
Technology probably outpace governance for quite some time. Yeah.
Exactly. Hey, let me take a moment to ask Jim Way. I want to be mindful if there are audience questions. Jim, can you give us a nod on what you've got there?
Unfortunately, nothing yet.
Nothing yet. Okay.
I'll prod him again.
No worries. That's very good. How do we think about what are the other technologies that relate to autonomy? Again, maybe Colonel Diller, you're seeing something in the DoD and the AFworks domain that relates to how this will move along quickly.
So I think that one of the things we found very interesting, both in the Agility Prime and as we start to look at our next Space Prime program, is the fact that there's opportunity to use low-cost sensors to get really exquisite solutions. And so that does a lot in terms of lowering the barrier to entry on the types of hardware, the places that you can manufacture the hardware, and being able to really create resiliency as well by taking distributed and numerous low-cost sensors with multiple different types of phenomenologies, and now then be able to merge them in clever ways algorithmically to create again, because the sensing piece of this is so critically important, right? Of knowing, having that situational awareness, the standard OODA loop of orient self, and those sensors play a key part of that. So we certainly seen a lot in the sensors. And then the other piece is the number of players in, and I like the idea of the augmented intelligence as opposed to the artificial intelligence, is there's so much movement in that space. I think one of the interesting areas that we're trying to explore a little bit is, what are those ways that for those companies that are really focused on the AI and autonomy, what are the proper ways to create incentives to commercialize that artificial intelligence? Oftentimes, the manufacturer of the sensor, of the platform, and of the algorithm aren't necessarily the same. And what are those ways that we can encourage open development that creates a good open market, good market competition, while at the same time creating opportunity for best of breed, while at the same time lowering the barriers to entry for those new, right, potentially fast followers that are going to really expand the market quickly and be able to push forward the innovation. And that's where we continue to look to the small business in particular with our SBIR program, STTR program, the AFworks open topic. You can learn more about that at afworks.af.mil, because we, of those 1,800 companies that we brought in, a good majority of those companies are in some form or not a majority of them, but the largest sector is in artificial intelligence, and that has multiple components as we discussed. Another piece certainly is the communications, resilient communications, and phenomenal opportunity there, again, using relatively potentially lower cost hardware as you look at different types of apertures and software defined radios that open, again, the capabilities there and create phenomenal public use missions as well as expanded commercial market. And to the point earlier, again, a place where we spend a lot of time is talking to investors and trying to understand where are those markets out there, where are those commercial markets that are out there that could be unlocked with just some of the minor changes in incentives and in policy, potentially in light investment from the federal government, or potentially even no investment at all, but just use of some of our existing resources and infrastructure that the taxpayers already invested in that may not be used at 100%. How do we offer that to the commercial sector so that that sector and the taxpayer are getting an increased ROI with these technologies?
I know there was a panel, I believe earlier today on training and education. What are the training and education implications of these kinds of capabilities? They seem substantial.
So I'll follow up just briefly at the risk of going back to back here, but we've recently, with our Agility Prime program, established under our Air Education and Training Command, Detachment 62, and they are responsible for really starting to explore this. I think, you can talk about all flavors of applications for AI and autonomy. I think there's interesting things that can be done that we have found, even in things like computer vision, that help augment the way we are doing training. With this Detachment 62, they are focused very much on what does it look like to, again, put the human in the right place, on the loop. The human, that we understand, we've established it just for understanding of things like large electrical power systems and what it looks like to do maintenance for our maintainers. And we understand there will be probably initially some piloted, but as we start to move into simplified vehicle operations and engagement with ground systems that help augment traffic management, for example, we see a wealth of opportunity there to understand a very different approach to operations where we're taking the human out of the loop and putting the human potentially on the loop. And those are exciting commercial opportunities for that training as well. And I think a lot of interesting academic work, so working closely with universities and research institutions.
Hey, Fred, how do you think about this at the state level? The talent piece of this?
Yeah, everything's shifting, right? So we're coming out with new amazing levels of piloted assisted aircraft, right? So, the piloting demands on the pilot is greatly reduced. I think earlier I mentioned personal air vehicles. I don't know if you guys ever did a search for people creating their own personal air vehicles in their garages and stuff. I mean, that's enabled because of the reduced piloting requirements and cheap technology, right? So, so education, while we reduce the requirements of the pilots, you're going to increase the need for like air traffic controllers, for example. Now, there's other technologies that are coming out, and Ohio is leading a remote tower initiative where we're virtualizing air traffic control towers at small to medium-sized airports that don't traditionally have air traffic control, and funneling that to control centers that one air traffic controller can operate multiple airports or help manage multiple airports in the air traffic. That there isn't really any training programs there yet, but we're working with our partners at Kent State who have a national leading air traffic controllers program and trying to gear that the air traffic controllers out of there to that new concept of remote air traffic control. So the state realizes that not really replacing people, we're shifting focuses on how we're going to push these aircraft of different levels of autonomy into the airspace, and whether it's a pilot with reduced piloting requirements, or it's a remote pilot altogether, we have to gear our educational institutions to be prepared for that. And that, again, that economic impact analysis was one of those tools that we came out with to help with the vision of how the airspace is going to change, and get it on our educational institutions' radars, that they need to start gearing their programs to answer some of the new questions.
Great. Mariba, Patrick, any comments on this?
On the workforce development and
The
education.
talent piece, yeah.
Look, I have to say that I'm incredibly sad at the state of the education talent piece in the US, especially when it comes to space situational awareness, the space traffic management stuff. Lots of companies always asking me, where are the students graduating so I can hire them right away? And I'm like, well, are you investing in the talent pool to grow these? Because they don't just grow off of trees. And so I think that, by and large, people just want government to, solve the whole thing. Industry is reluctant to really participate in helping develop the talent pool for this skill set. They want to just hire them, and they don't realize that there's a long pole in the tent. It's not just calculus and differential equations. It's a bit more than that. This area is very transdisciplinary, so I can see more and more students coming through my classrooms that are trying to not only major in aerospace engineering, but also major in public policy and these sorts of things, because they realize that there's a nexus there. It's critical to solve these sort of wicked problems. So yeah, it's pretty sad, and I'm just, not to put too much dirty laundry out there, but there are more and more companies, big companies that, look, there's one that told me, that has been funding me for the past 3 years, that said, we have new management and they just don't see the value to academia. So this is the last bit of funding we're going to give to you. Okay, well, 3 years from now, if I'm still around, you'll be able to knock on my door and say, yeah, I think we made a mistake on that one. So I just, and places like the National Science Foundation, SSA and STM is very applied. So they're like, oh, that's somebody else's problem. It's not basic enough, right? Is what I hear from some people. So it's almost like this area we're all agreeing is critical has no scientific home for some solid investment. So yeah, that wasn't very optimistic, but I'm just being real.
Well, hopefully we can all work on that together, actually. Patrick?
Yeah, I think you made a good point about this. It's really one of the critical interdisciplinary space issues. There are a lot of space issues that are primarily technical, and there are even some space issues that are primarily social science based. But this one crosses the divide, or it actually resides quite squarely in the nexus. I think there's probably two issues. One is the challenge. One has to do with the solution. So I don't think the awareness of the problem is where it should be right now. I just don't think people realize kind of what the space environment looks like and what it will be in 10 years. And I think if people knew more about it, they would realize the direness of the challenge. And we do need people to step up and start getting involved in this. And I think the second thing is maybe the solutions. So, I don't want to disparage space traffic management or anything like that. It's not the most interesting for some people to talk about space traffic management, but a mission, an active debris removal mission, could be quite inspiring. Actually setting a mission up there to grab onto a rocket body or something and bring it back down to Earth and say, you know what, we just potentially saved this many spacecraft and contribute to the environment. And people will realize that it's a little bit like the environmental challenge that we're facing now. It's the space environment. And so both things could really draw some more folks into the field.
It does have an incredibly diverse level of complexity. I will say that from personal experience, actually. Hey, Jim, I just wanted to check in with you one more time. I know we're fighting the clock right now, but you might have a question from the audience.
We do, yeah, and we got a couple, but this one, comes from William. So it had to do with the rules of the road discussion component. So can you talk about the coordination policing of geo-orbital slots and whether something analogous may end up being applied in some fashion to the LEO slots, especially with respect to the large constellations?
So the question, I think, belies a level of sophistication that is well beyond the level of discussion about rules of the road. Obviously, where we're at right now at the UN in Copos, Patrick mentioned it before, there are a range of international discussions going on amongst the diplomats in the international standards bodies and other places to look at issues, more technical issues related to those kinds of questions. Patrick, you want to say anything about this?
Just quickly, I think the idea of orbital slots may be challenging in LEO orbit, but you could conceive of maybe an upper limit on spacecraft in LEO or something like that. Probably challenging to implement, but you're welcome.
And enforce.
Yeah. Although the ITU and GEO orbital slots, it seems quite effective.
Right. Well, hey, it's 3:45. This has been great. Thank you all so much. Kevin, any last words?
No, I just want to thank everybody for their insightful comments, and sorry if we didn't get to some of the other questions from the audience, but happy to take them one-on-one, I'm sure.
Good. Yeah, maybe I'll copy them and send them your way, and you can answer them directly or put them to the group. That'd be great. So everybody, thank you so much for doing this today. We really appreciate your time. And what a great way to end the event. You know, it provides a lot of food for thought. So with that, we thank you all very much. And I'm going to get into the closing logistical stuff. So, so thank you to all of you. Yeah, thanks, Kevin. And thank you to all of our panelists and speakers throughout the entire event. We really appreciate your time and your contribution to making this such a success. And thank you to all of our event sponsors, of course, the Aerospace Corporation, Aerojet Rocketdyne, Ball Aerospace, Dynetics, Lockheed Martin, Maxar, Moog, Teledyne Brown Engineering, and our media sponsor, Space News. We could not do this without you, so we thank you all very much. Thanks to everyone at the NASA Glenn Research Center. We appreciate all of the attendees, plus all of the leadership contributions to making this happen. And thank you to our planning committee. It's like we've said before, it's a large, diverse group. And again, we could not do it without you. And most importantly, thank you to all of you, our attendees. You again couldn't do it without you, and we're so happy that you joined us, and hopefully you got a lot out of it. I'd like to now welcome in Alan DeLuna into the room, AAS president, for some closing words. Alan?
And I do want to again thank the AAS staff, Jim and Kelsey and Abigail, for managing this. We do not do pre-recorded presentations or sessions. Everything that you guys saw in the past 3 days was live, less the promo videos that we got from our sponsors and the videos showing capabilities of some of the centers. But the sessions and the speakers were all live. So managing all that is no small deal, especially when you consider that we had about 50 different individuals that had to be managed through this, all the way from making sure the systems worked a week or two ago to shepherding them through the process the past 3 days. So our staff did a great job. And I'm glad to say that we may not have to do it this way again for a little while. We'll certainly keep this kind of virtual event in our quiver because our team does a great job. But our next event will be face-to-face, and I look forward to seeing you all there. And Jim Way, why don't you go ahead and tell us about it?
Sure, yeah. We're very excited to be going back to Knockwood in-person event. So please join us for our return to that at the 2021 AS Von Braun Symposium. That'll take place October 12th through the 14th down in Huntsville, Alabama. Happy to be back down at UAH and working with all the good folks at Marshall Space Flight Center. And remember, AAS is at astronautical.org. Please go to our site, find out more about us there. Join us. Membership is cheap, and we'd love to have you on board. And with that, that concludes the 3rd annual John Glenn Memorial Symposium. Thank you all for attending. Take care. We'll see you at the next one.